Bismillahirrahmanirrahim. Assalamualaikum. A very good day to you all. In this video, I continue for the chapter 8 from the book Shigley Mechanical Engineering Design. This topic will discuss about 8.8 relating torque to bolt tension. All this content is taken from that book, and all the images is taken from that book itself and also from randomly from Google Images. Okay, remember about bolt preload. What is a bolt preload? Bolt preload is when bolt tension is created together when the nut is screwed onto the bolt to help two materials together. Okay, when the tension reaches its optimum preload, the working load will be distributed onto the installation material. Meaning that when you tighten the bolt and when it reaches the maximum value it can get, the force you give extra force, it will be distributed onto the plate. Okay, it distribute onto that plate, okay, that you want to connect. Okay, so having learned that high preload is very desirable in imported bolt connection, we must consider means to ensure that preload is actually developed when the parts are assembled. Meaning that, in other words, you make sure the bolt is tightened tightly. Okay, that is the meaning by this statement. Okay, meaning by this statement is actually developed when parts are assembled. Because if you are not tightened tightly, preload is not going to happen at maximum. Okay, because only when you tighten it tightly, then it become preload, and over tighten the load we distribute onto what it become onto the plates that it connected. And before that preload came, okay, before that preload value, it does not reach the preload value. Okay, so that is why you must tighten it tightly. Okay, this is the picture of bolt preload I taken from Google Images. Okay, how to measure the screw elongation? Okay, here is the screw. Okay, usually you measure with micrometer. Okay, you do not measure with this ruler, this kind of ruler. You measure with a micrometer. You measure how long it will become elongate when you are tightening the screw. How long it elongate. The value will be given in micrometers. You cannot see with your eye. Okay, but elongation of screw usually cannot usually be measured because right at the end is often in a blind hole. Okay, this is cardboard. I make a hole inside it. You see this hole. Okay, and I put assembler like this. Let's say this is a plate. So when you do the operation, you will do it on the upper side. Okay, on the upper side. This lower side, how can your hand reach and how can your eye see? Okay, how can your hand reach and how can your eye see? You cannot see with your eye. This is called the blind side. Okay, the blind hole. Okay, so you have to use the torque wrench. Okay, this is the torque wrench. Given I taken this image from Google. This is torque wrench. Okay, when you given a specific torque to it, and then it will go into that specific torque. Okay, if beyond that, it cannot. It don't. It do not. It do not wrench anymore. Okay, so this is the torque wrench. Snug tight condition. What is a snug tight condition? Turn out the method request for redefine the meaning of snug tight condition is the tightness attained by few impacts of the impact wrench, a full over of person using an ordinary wrench. Okay, so I give example to this my cup holder. Okay, my mug. Okay, I put coffee in it. Okay, so I'm tightening it. Okay, when I tighten it to the maximum, I cannot move anymore. I cannot move anymore. It is a snug tight. Cannot move anymore. So ever you give the force, the load, it cannot go. Okay, it cannot be. It cannot be wrenched anymore. See, this is called the snug tight condition. Okay, this is called the snug tight condition. When you are using the bolt, okay, when your hand cannot go, cannot range in anymore. The same case, this is a snap type condition. So the torque estimation is given by this equation. T is resemble the torque. Torque is equal to initial force Fi times the dm minor average of minor and major diameter uh, uh, over 2. Okay, and in bracket L, the length of the thread, okay, this part, this portion, okay, this portion, this is the length of the thread. Okay, this portion, this thread, this kind of thread, okay, this is the portion of the thread. Okay, the thread, not the grip. This is called the grip. The one that has no thread is called the grip, and L is the portion of the thread itself. Okay, and F is the friction. Okay, you get from the table. The alpha is the angle of the thread. Okay, if you can measure the angle of the uh, your thread, this is the alpha, and you get from the second value lah. And FC, C stand for the collar. Okay, this is the collar. I put C is the collar. Okay, and that's all lah. You put in all in the equation, and you can get the torque required. The torque, you put the value from the torque in the range. Okay, in the torque range, and then this is the value that you want to do lah. From put the value on the torque range. Okay, the equation in the previous slide, we continue here to estimate the torque. Okay, the diameter of a washer face of hexagonal side is this hexagonal is the same as width cross flex and equal to 1/2 times the nominal size. Therefore, the mean collar diameter is DC equals to D plus 1.5 D. Okay, over 2. So 1.25 D. So this is the collar diameter. This is the collar. Okay, this is the collar diameter, and 1.25 D. This is the diameter of the thread of the screw. Okay, diameter of this. So estimation can now be arranged by F equals to this equation. Okay, Fi is the initial force. Okay, and D is the diameter of the screw. Okay, define the torque coefficient at the term in bracket. So this is torque coefficient you can get from the this equation, and equation can be written by T equals to K Fi D, which is K is the torque coefficient you get from this equation, and Fi is the initial force, D is the diameter of the thread. Okay, and the coefficient operation depend on surface smoothness, accuracy, and degree of lubrication. Remember, lubrication is an important factor. Never neglect lubrication. Okay, for most critical parts. Okay, this intrinsic effect K equals to 0.2 for F equals to friction of collar equals to 0.15 no matter what the side bolts are employed, and no matter what the threads are coarse or fine. Okay. Okay, and this statistical analysis done by Blake and Kurz published result of numerous tests on the torque of bolts by subjecting the data to a statistical analysis. You can learn something about the distribution of torque coefficient and resulting preload. The Blake and Kurz determined the preload in quantities of unlubricated and lubricated bolts of size ½ inch, 20 U and F. Okay, when torque to 800 pounds inch. Okay. So this correspond roughly to M12 times 1.25 volt torque to 90 Newton meter. Statistical analysis of these two groups both convert to SI unit are displayed in table, which is in the next slide. Okay. So this is among the statistical analysis that you can done to do people have done to uh, to see what is the torque coefficient and the preload. Okay. And this is the table of preload and table for 8.15 for torque factors. Okay, you will use this table in the subsequent examples. We will do the examples in the next video. Okay, so that's all for this video. I see you in the next video. We are doing the example 8.3. Okay, so thank you very much.